Hello, in this video we're going to be finding particular solutions to differential equations using an initial condition. If you're looking for finding general solutions to differential equations using separation of variables, we have another video for you on the channel, so go ahead and look for that. But everything that we're going to do today, our equations are going to be separable. So we have a generic form right here. I have sum dy dx equals a function of x times a function of y. We can separate this by moving our function of y over on the left side, and our function of x stays on the right side. So we're putting all of our y's on one side and all of our x's on another side. From there, we're going to integrate both sides. We're going to integrate with respect to y on the left, and we're going to integrate with respect to x on the right. Once we do that, we can find our particular solution by plugging in an initial condition. So let's go through a few examples. Starting with number 1, I'm going to rewrite my differential equation. And I'm going to start by separating the variables. So let's see, I'm going to divide by x squared plus 4 on both sides. I'm going to multiply by dx on both sides. And I'm going to divide by y on both sides. Once you have separated the variables, notice that I have all my y's on the left side and all my x's on the right side. Once you have done that, we are going to integrate both sides. On the left side, I'm going to have the natural log of the absolute value of y. There will be a plus c, but we're just going to put our plus c on the right side. On the left side, I do need to use u substitution. So my du is 2x dx. I have x dx, but I need a 2. That means I also need a 1/2, so I'm multiplying by 1. And this is going to be 1/2 1 over u du. And when I integrate and plug back in, it's going to be 1/2 natural log of x squared plus 4, and then we'll put our plus c. At this point, we want to simplify enough, and then we want to solve for c. You could technically solve for c right here, but I prefer to make our equation a little bit simpler. So I'm going to say natural log of absolute value of y equals 1/2 natural log. Notice that x squared plus 4, no matter what you plug in for x, you're going to get a positive number. So we can drop the absolute value. In order to get rid of the natural log in front of the y, we need to exponentiate with e on both sides. That's because e and natural log are inverse functions. I'm going to continue my work up here. We get absolute value of y equals e to the entire right side of the equation. From here, I'm going to say this is e to the 1/2 natural log of x squared plus 4 times e to our constant. And that works because if I have the same base, you can add the exponent. So if I wanted to go backwards, I would have that plus in between. Now, e raised to some constant is just some constant. So I'm going to say we have e to this exponent times some constant, and I'm just going to move the constant out front. Next, I'm going to use my power rule for logarithms, and I'm going to move my 1/2 up to be an exponent. Just like we did with our exponentiating, e to the natural log, those two functions undo each other. So I end up with just x squared plus 4 to the 1/2, which is the same thing as the square root of x squared plus 4. So I would say at this point, let's solve for c. So we know that, what did they tell us? They said y equals 2 when x equals -3. Now we do still have the absolute value around the y. We will deal with that after we find our c. But I'm going to plug in 2 and negative 3. And let's solve for c. So I have a 2 on the left side. Negative 3 squared is 9. 9 plus 4 is 13. Divide by the square root of 13 on both sides, and c is 2 over rad 13. So I'm going to rewrite our equation, and I'm going to plug in for c. Our last step is we need to get rid of this absolute value, because I don't want to know what absolute value of y equals. I want to know what y equals. So just like if I do a side example, very simple. If I have the absolute value of x equals 2, what can you plug in for x to make this a true statement? Well, you could plug in negative 2, or you could plug into 2. So that's why you probably learned x equals plus or minus 2. Similar situation right here. Y can equal plus or minus 2 over rad 13 times the square root of x squared plus 4. But we need to decide, do I want the positive or do I want the negative? And you're going to decide that based off of your initial condition. So notice that when you plug in negative 3, I want y to equal positive 2. So if I plug in negative 3, this is going to be, again, 9 plus 4. So my rad 13 and my rad 13 are going to cancel, and I want a positive 2. So that means that for this, I want to pick the positive. So in this case, my answer is going to be y equals positive 2 over rad 13, rad x squared plus 4. And that is going to be our final answer. So that is our first example. We have a couple more. Example 2, so we have another initial condition. It's written a little bit differently, but keep in mind this is x equals 0, y equals negative 4. And we have a new differential equation. So let's start this problem. I'm going to start by separating the variables. So I'm going to multiply by y on both sides, and I'm going to multiply by dx on both sides. Now that the variables are separated, we can integrate both sides. We get 1/2 y squared equals e to the x, and I'm going to put my c over on the right. Let's start solving for y. So I'm going to multiply both sides of the equation by 2. I get 2 e to the x on the right, technically plus 2c, but 2 times a constant is still just a constant. So I'm just going to leave this as a c. I would say from here, let's find our initial condition. Let's find our c using our initial condition. It technically doesn't matter what step you use to find c, but let's do it here. So we get negative 4 squared, because we're plugging negative 4 into y, and we're going to plug 0 into x. So I get 16 equals 2 plus c, so c equals 14. So now I have y squared equals 2e to the x plus 14. We're going to now get rid of the squared, so I'm going to square root both sides. Don't forget the plus or minus out front. Y equals plus or minus the square root of 2e to the x plus 14. Now, same thing as the previous problem, we need to decide whether we want the positive or the negative. So to do that, you're going to look back at your initial condition. I'm going to show my work up here. I want y of 0 to equal negative 4. So I want negative 4 to equal, and then I have my plus or minus, 2e to the 0 plus 14. And if I simplify the right side, I get 2 plus 14, which is the square root of 16, so I get plus or minus 4. But if I want both sides to match, I want to choose the negative. So in this case, my answer is going to be y equals negative square root of 2e to the x plus 14. And that is your answer. We have one more example. Let's go to example 3. Here they say find the equation of the curve that passes through the point 1, 3 and has a slope of y over x squared at any point xy. So 1, 3 is your initial condition. And since y over x squared is your slope, that means that dy dx equals y over x squared. So notice we still have our same situation. So we're going to start by separating our variables. I'm going to divide by y on both sides. So I have 1 over y dy. 1 over x squared is the same thing as x to the negative 2. And then I'm going to multiply both sides of the equation by dx. Once you have the variables separated, we're going to integrate both sides. We get natural log of the absolute value of y equals negative x to the negative 1 plus c. Just like we did on that first problem, to get rid of the natural log, we're going to exponentiate with e. We get the absolute value of y equals e to the negative 1 over x plus c. Also similar to the first problem we did, I'm going to rewrite this as e to the 1 over x times e to the c. And then e to the some constant is still some constant. So I'm going to say I have a constant times my e to the negative 1 over x. Let's figure out our initial condition, or sorry, I keep saying that. Let's figure out our c using our initial condition. Our initial condition was 1, 3. So we're going to plug in so I get 3 equals c times e to the negative 1. This is the same thing as 3 equals c over e. Multiply both sides by e, and I get c equals 3e. Plug in, so from here, I get absolute value of y equals 3e times e to the negative 1 over x. And maybe let's keep working on a new line. Let's make our exponents a little bit nicer. So this is y, absolute value of y equals 3e to the 1 minus 1 over x. And this is the same thing as 3e to the x minus 1 over x if we do some adding fractions. At this point, with our absolute value, we want to get rid of it. So we're going to say y equals plus or minus 3e to the x minus 1 over x. And just like both of the other problems, we want to decide if we want the positive or the negative. And just like the other problems, we're going to use our initial condition. So I want 3 to equal plus or minus 3e to the 1 minus 1 over 1. Our exponent simplifies to 0. E to the 0 is just 1. So I get positive 3 equals plus or minus 3. And if I want both sides of the equation to be equal to each other, I need to choose the positive. So my answer is going to be y equals positive 3e to the x minus 1 over x. And that is our final answer. So these were a few problems of solving differential equations and getting particular solutions. Thank you for watching.